You grab a glass, your fingers tighten. Tiny ridges press into the surface, and every one of them is making your grip worse. You were told the opposite. Fingerprints are tire treads for your hands. More friction, better hold. It's in school books. It's on museum walls. It's wrong. Manchester, 2009. A researcher named Peter Warman is doing something faintly absurd for a living. He clamps a human finger into a testing machine, presses it against a sheet of acrylic glass, and drags it sideways, over and over at different pressures. He measures two things: how hard the finger resists sliding, and how much skin is actually touching the glass. If the tire tread story is right, the ridges should bite. They don't. The ridges cut the contact area by about a third. And on a smooth surface, less contact means less friction. Warman and his supervisor, Roland Ennos, publish it under a title that leaves no room. Fingerprints are unlikely to increase the friction of primate fingerpads. Your fingertips would hold that glass better if they were completely smooth. And the tire comparison was backwards the entire time. Racing teams run slick tires, no tread at all, because on a dry track, maximum rubber means maximum grip. Tread exists for exactly one job: moving water out of the way. Everywhere else, it costs you. So if they aren't for gripping, what are they for? Same year, Paris. A physicist named Julian Scheibert builds a fake finger. Soft rubber skin, pressure sensors underneath where the nerves would sit. He makes two versions, one perfectly smooth, one with ridges spaced like yours. Then he drags both across a rough surface and listens. The smooth finger produces mush, a blur of vibration with no pattern. The ridged finger produces something completely different, a clean tone. The ridges chop the texture into a rhythm. They turn a scrape into a frequency. And that frequency lands at roughly 250 hertz, which matters because 250 hertz is almost exactly the peak sensitivity of your Pacinian corpuscles, the deepest touch receptors in your skin, the ones that read fine texture. Your fingerprints are tuned to them. They aren't treads, they're antennas, a filter that takes the noise of the world and shifts it into the one band your nerves hear best. It's also why the ridges curve. Loops and whirls mean that whichever direction you swipe, some ridges always cross the texture at an angle that works. And the resolution is genuinely hard to believe. In 2013, Lisa Skedung's team in Stockholm blindfolded 20 people and had them stroke sheets of plastic. Some sheets were flat, others carried wrinkles 13 nanometers tall. 13. A sheet of paper is 7,000 times thicker than that. They felt it. Your finger isn't a clamp, it's a scanner. Except the story isn't finished. In 2020, a team in Birmingham and Seoul pressed fingers onto a glass plate and filmed the contact from underneath with lasers. And they caught the ridges doing something nobody had measured. When your finger is too dry, the furrows between the ridges hold sweat in, softening the skin until it sticks. When your finger is too wet, those same furrows turn into drainage channels and pull the water away within seconds. Wet or dry, the ridges drive your skin toward one specific moisture level, the level where friction peaks. So fingerprints do help you hold on, just never by biting into anything. They do it by managing water. The old answer was right about the result and wrong about everything else. Then there's the strangest evidence of all. Koalas. In the 90s, an anthropologist in Adelaide put koala paws under a microscope and found loops and whorls that are, at that scale, essentially indistinguishable from ours. A forensics lab could mix them up. Koalas are not primates. Their closest relatives, wombats and kangaroos, have nothing like it. Evolution built the same machine twice, independently, for an animal that spends its life reaching into eucalyptus branches and pulling out handfuls of leaves. And then there are the people with none at all. Adermatoglyphia. 5 known families on Earth, 1 mutation in a gene called SMARCAD1. Fingertips completely blank. In 2007, a Swiss woman from one of those families landed in the United States and couldn't get in. Her face matched her passport. Her hands matched nothing. The condition picked up a nickname in the medical literature, immigration delay disease. Her other symptom is the tell. Her hands sweat less than everyone else's. The ridges and the water were never 2 separate systems. All of which quietly explains a few things you've probably blamed on yourself. Your phone rejecting your thumb after a shower or on a dry winter morning. That's the moisture window. Your ridges are out of range. The reason you lick a fingertip to turn a page. You're not being gross. You're doing by hand what the furrows normally do for you. And why you can feel almost nothing through gloves. You haven't lost pressure. You've lost the 250 Hz signal. The antenna is disconnected. One last thing. The ridges finish forming around week 17 in the womb, buckling as the pads on your fingertips shrink beneath the skin. The broad pattern is genetic, the fine detail is not. It comes from pressure, from fluid, from how you happened to be lying that week. Which is why identical twins with identical DNA have different fingerprints. The thing we use to prove who you are was never written by your genes. It was written by an accident, months before you had a face. So next time your phone refuses your thumb, don't rub it on your shirt. Breathe on it. Warm, damp air pushes your skin back into the friction window in about a second. Check out this video next and subscribe here so you never miss a new one.